Yeah, shall we start, sir?
Yeah, please.
Yeah. A warm welcome to one and all present here. I am Dr. Sharvari, Professor and Head, University Department of Information and Communication Technology, MGM University, Aurangabad. I am thankful to MGM University and World Resources webinar team for giving me the opportunity to work as a session chair for this workshop on advanced AI. Thank you so much. The agenda for this workshop is we have 7 eminent speakers to speak on advanced AI. I heartily welcome all the speakers, Dr. Rajasekaran, Dr. Dinesh Goyal, Dr. Pankaj, Dadheech, Dr. Kranti Ghag, Dr. Fabiana Sepe, Dr. Igor Jurcic, Professor Surjeet Dalal, and all the participants. Once again, I welcome you. Dr. Rajasekaran will speak on TF-IDF based text mining for 15 minutes, followed by Dr. Dinesh Goyal, Dr. Pankaj Dadheech on precision farming, applications of AI and IoT in agriculture for 15 minutes. Dr. Kranti Ghag will address us on sentiment analysis on Twitter data and movie review data set using Colab notebook. She will also speak for 15 minutes. Dr. Fabiana Sepe will throw a light on AI for social robots in airport setting for 15 minutes again. And Mr. Igor Jurcic will share his knowledge on importance of AI applications in Telecom 4.0 business for 15 minutes. Lastly, Professor Surjeet Dalal will speak on explainable AI in healthcare system. After this, there will be an interactive question and answer session for 5 minutes. So with the permission of all the speakers, I'll ask the first speaker. So please join me again to welcome Dr. Rajasekaran, who is currently working in a Department of Information Technology, University of Technology and Applied Sciences, Ibri Sultanate of Oman. He is working in AI and algorithms discipline. He has expertise in machine learning, classification, supervised learning, feature selection, data mining, knowledge discovery, data clustering, prediction, unsupervised learning, advanced machine learning, KNN, text mining, and cluster analysis. I request Dr. Rajasekaran to address the audience on TF-IDF based text mining. Over to you.
Good afternoon to everyone. Sorry, good evening, right, in India. Thanks for the warm welcome. I would like to thank MGM University and World Resources webinar team for giving me this opportunity to share my experience in this forum. Let me share my screen. Yes. Is it visible? My screen is visible. Am I audible?
Yes, sir. You are audible as well as your screen is also visible.
So in today's session, I'm going to share my experiences in TF-IDF based text mining using Python. First, what is TF-IDF? Term frequency. TF is term frequency, which is the measurement of how frequently a term occurs within a document. In one document, how many times a particular term is occurred, that we are going to measure with the help of term frequency. Again, term frequency is the measurement of how frequently the term occurs within a document. I'm going to use the formula for term frequency is number of items, the term number of times the term appears in the document divided by total number of terms in the document. So the term frequency is represented as TF T comma D. The T represents the term, D is your document. So term frequency is number of times the particular term exists or occurred in the document D divided by total number of terms in the document. This is what the definition of term frequency. Also, inverse document frequency, IDF stands for inverse document frequency, which is the inverse document frequency is measure of whether a term is common or rare in a given document corpus. Means whether it is a common term means it appeared many times, or it is a very rare term appeared only once or twice in the document. That we are going to identify with the help of inverse document frequency, IDF. The formula for IDF is log of number of documents in the corpus, and number of documents in the corpus contains the particular term which you want to identify. So this will help you to identify or measure that the particular term is a common or a frequent term or a rare term we can identify. N is total number of documents, how many documents we have to analyze the particular word, or DFT is number of documents in which the term T exists. TF-IDF is again, TF-IDF is a term frequency, inverse document frequency. It's a statistical measure that evaluates how relevant a word is to a document in a collection of documents. So how a particular word is influenced in the document or in the collection of documents, that we are going to identify, which will be applied in many places, whether maybe sometimes, you know, in Twitter, everywhere we are going to calculate the comments or feedbacks which the people are giving. So based on the term, using this TF-IDF, we can identify how the comments are given. I mean, same word is given frequently or by most of the users. TF-IDF is again, it is a statistical measure that evaluates how relevant or influence a word is to a document or in a collection of document. Formula for TF-IDF is TF-IDF equal to term frequency in multiplied by inverse document frequency. You know this formula already explained. TFD, T comma D is number of occurrences of the term T in the document D. NTD is total number of terms in the document. N is the total number of documents in the corpus. DFT is number of documents in which the term T exists. I'll just give you a simple example to make you understand this concept of TF-IDF, how it will identify the influence of particular term in the document. So I'm just going to take two simple sentences like D1 equal to the man is above the tree. D2 equal to the lion is under the tree. So how many times term frequency is number of times the particular term is occurred in document 1. TF term frequency for document 1. These are the terms. I have to take all the terms which is available in both the D1 and D2. The man is above the tree. And here also the is repeated, is repeated, the tree is repeated. Only the new words are lion and under. I have taken those also. Now, this TF term frequency for D1 means how many times these words occurred in D1. The occurred only once, and total number of words in the document 6. 1 by 6 will be calculated. And man occurred only once, total number of words is 1 by 6. Is the next word which is occurred once in this document D1. Above also occurred once. There is a difference between this the and this, because here T capital, here small. This will be considered as different. This is also occurred once, and the tree occurred once. So these are the words occurred once in the document D1. So in the same way, I am going to calculate term frequency for document 2, D2. The is there, it occurs only once, 1 by 6. Lion, it's new, it's not there in the previous document. So lion is occurred only once. Is already it is there. So is also once occurred in document 2. Like that, every word which is present in your document, you can analyze. Under, once it is occurred. the once it is occurred, tree once it is occurred. So I'm just calculating term frequency in document 2, and IDF will be calculated inverse document frequency. We know that inverse document frequency, the formula is number of documents in the corpus divided by number of documents that the corpus contains the term. Here you have two documents, right? Log of 2 by 2. Number of documents is 2, D1, D2, divided by in number of documents the particular term is occurred. The is occurred in both the documents D1 and D2. So it is 2. Log 2 by 2 is 1. Log 1 is value is 0. Then man, next word is man, which occurred in only one document. So this is 2 by 1, log 2 by 1 equal to 0.3. Total document is 2, and the word man occurred in only one document. Like that, you have to calculate IDF. So the next one is total document is 2, log of 2 by in number, how many documents the word is occurred? 2 documents it is occurred, 2 by 2 is 0. Above total documents 2, it occurs in only one document, 2 by 1 equal to 0.3. Likewise, you can calculate inverse document frequency for all the words. Then the TF IDF will be calculated just multiplying the TF value and IDF value. TF IDF 1 by 6 multiplied by 0, it is 0. Here 1 by 6 multiplied by 0.3, it becomes 0.5. So I'm just calculating TF IDF for document 1 and TF IDF for document 2. It will just the repeated words, the values will be 0. The other words value once it is occurred, it is 0.5. You know that how it is calculated. Now let us do this example by defining these documents in Python. Also, I'm going to explain the same thing in Python, how it can be evaluated, and also manually how we can do this. The formula already explained. See here, just I'm taking, imagine the terms appear 20 times in a document that contains total of 100 words. The term frequency of can be calculated as follows. TF equal to number of times the term occurred and total number of words in the document. 100 words, the particular word occurred 20 times, 20 divided by 100, 0.2. The same way we can calculate IDF, which means inverse document frequency. The document contains 10,000, there are 10,000 documents in the corpus, and 100 documents contains the particular word. So 10,000 divided by 100 log value becomes 2. And using these two quantities, we can calculate TF IDF just multiplying. The TF IDF value becomes 0.4. Before going to this, I will just show this example in Python, how it will be done. So I have D1 equal to the man is above the tree. D2 is the line is under the tree. Just I have taken two strings in which I am going to calculate the TF IDF value. First, I would like to find the words in a document. How many words? Each words will be separated using the split function. The words will be splitted. So I just run this word. The words are splitted now. Then if I print, see the first document D1 words will be splitted and stored it in bow1. D2 values will be splitted and stored it in bow2. If I print bow1, just the word, the sentence will be splitted in each word and displayed separately as a list of items. Bow2 also. Now here I am going to merge these two sets. So these two sets are merged and the duplicate values will be ignored because sets will not allow the duplicate values. I just going to define two dictionaries which will have empty. Dictionary means you know that which have the keyword and its value. So each word and just initialize 0. It has appeared 0 times. Just initialize two dictionaries, right? In first dictionary and the second one is for the second string. Now I am going to calculate how many times the word is repeated. For word in bow1, word count of that particular word if repeated, it will be added. How many times the word is repeated. So if I print this word dictionary 1, you see now how many times the word appeared. The appeared once, tree appeared once, man, above, is, These are all the words appeared once in document 1. Same when I display the word dictionary 2, what are the words appeared in document 2, which will be reflected, how many times it occurred. I'm just calculating TF values with the help of, you know, that formula, count how many times the word occurred, and bow count the particular word, how many times, how many documents it is there. It is calculated with the help of this formula, and you can display TF1 value, which is calculated based on your dictionary 1. Sorry, first text value. So above once, man once, the once, tree, is, the, these are the terms appeared only once, and TF value will be calculated here. And this is for the document 2, the second document, what are the words appeared how many times, and it is calculated TF value for document 2. We know this. And with the help of this, I'm going to calculate IDF value. IDF value also, I already told you the formula. What is the formula for IDF? Number of documents in the corpus divided by number of documents in the corpus contains the term. So number of documents in the corpus divided by log of number of documents, n is the number of documents, divided by how many documents has the particular term, which can be calculated. And IDF values I can display here. So IDF value will be calculated and display for this. After that, I can calculate TF-IDF. For calculating TF-IDF, we have the formula for TF value multiplied by IDF value of the particular word. If you run this, you will get the TF-IDF value, and just I'm going to display the TF-IDF value. Whatever value we calculated manually, only these words are appeared once. Whatever words have the value 0, which appeared frequently in both the terms. This is how we can calculate TF-IDF value, and it can be displayed also in a table. In some particular line, I think I did not execute. So this is how we can able to calculate TF1 and TF2 value. Also TF-IDF value we can calculate. I hope this is clear for you. TF-IDF calculation. Also we can able to calculate, just to export some documents, and you can able to calculate. Apart from this, this is the function which I defined manually. I calculated even in Python code. Also you have built-in functions to do all these things. Take the sentences as a corpus, and you have built-in functions to convert these values into the split these and create the set. After that, you can calculate TF-IDF values using the built-in functions. That is also possible. So in both way you can use. Also apart from this, you can also be able to add some document, and it will take the values from the document, it will calculate. But since there is no time, I could not able to go with the document. Let me explain the possible applications of TF-IDF score. The TF-IDF can be used in many places like machine learning and natural language processing, information retrieval and text summarization, clustering and classification of documents, topic extraction. Maybe if you want to extract a particular title or particular word from the document or keyword from the document, yes, you can identify. Even when you publish journals, you can find using these keywords, which are the articles related with your topic. Unifying the data received from multiple data sources, text mining, finding the authors of anonymous articles, spam filtering, search engines. Like in many different places, we can use this TF-IDF. Also, we have certain advantages and disadvantages of TF-IDF. The advantages, it is easy to compute. provides basic metric to extract the most descriptive terms in the document. You can easily compute the similarity between two documents using TF-IDF. The disadvantages: TF-IDF is based on a bag of words model. Therefore, it does not capture the position in the text, in which position that the word is occurred. Semantics or co-occurrences in different documents. For this reason, TF-IDF is only useful as a lexical level feature, cannot capture semantics. So the hands-on application already I discussed with you. These are my references. With this, I would like to conclude my topic. And once again, thanks for the opportunity given by the team and all the participants also. Thank you so much. I hope I am on time.
Thank you, Doctor.
Yeah, thank you. Thank you so much, Dr. Rajasekaran, for your valuable words.
Thank you.
Next, we'll be having address by Dr. Dinesh Goyal and Dr. Pankaj Dadheech. Dr. Dinesh Goyal is working as a professor in Department of Computer Science and Engineering. He is also working as an accreditation advisor and director at Purnima Institute of Engineering and Technology, Jaipur, Rajasthan, India. His disciplines are information security, image processing, cloud computing and security, big data analytics and machine learning. And Dr. Pankaj Dadheech is currently working as an associate professor at Department of Computer Science and Engineering, NBA accredited at SKIT, M&G, Jaipur. His areas of interest are high performance computing, cloud computing, cyber security, big data analytics, Internet of Things. He has disciplines in computer security and reliability, distributed computing, computer communications. He has also expertise in high performance computing, load balancing, parallel and distributed computing, parallel programming, parallel processing, MPI, cluster computing, grid computing, performance evaluation, virtualization, big data analysis, data mining. So I request Dr. Dinesh Goyal sir and Dr. Pankaj Dadheech sir to guide us on precision farming, applications of AI and IoT in agriculture. Over to you, sir.
Thank you, ma'am. So I will start first. So our topic is precision farming, applications of AI and IoT agriculture. So what is mean by precision farming? So first, precision farming or precision agriculture is the science of improving crop yields and assisting management decisions using high technology sensor and analysis tools. So precision agriculture is a new concept adapted throughout the world to increase production, reduce labor time, and ensure the effective management of fertilizers and irrigation process. So the challenges in agriculture are like agricultural disparity, farming setup, personalization, vital stakeholders, demanding customers, and infrastructure bottlenecks. So how to tackle these challenges? So or by producing make food and by producing more food with less land, limited water and fewer resources, hence making farming profitable for smallholder farmers. So the advances in ICTs are used. These are the various advances like convergence of technologies, miniaturization, speed of processing data, increase of bandwidth, increase of storage capacity, networking, wireless technologies. So what are the applications of ICTs in agriculture? So in Ministry of Panchayati Raj established information kiosk in 5 panchayatis in India, and Department of ICT or DIT, Department of Information Technology initiated over 2 lakh common service centers under the National E-Governance Plan or ITC. It has added 11 new e-chaupas a day and has scaled up to 1 lakh e-chaupas by 2016, covering 1,50,000 villages in 25 states. So use of ICT for by all NARs, so National Agriculture Systems and Agriculture Extension, Agribusiness and Marketing. So these are the various applications. Then market information, production information in networking of markets through ICT, like in commodity exchanges, future trades and value chain management, like knowledge intensive post-harvest management and traceability, quality certification, supply chain management. These are the various IPCs for agriculture department. And what are the various smart farms? You can see the various digital technologies are using. So for smart farms, the future of farming, in past we are using the plow in 19th century, then green revolution comes, then GMO revolution, means it is genetically modified organism based techniques are used. Then in 1980s GMO revolution and the mechanized revolution from 2008. Then in present, the confused farmer having the data from the various drones or sensors or satellite and weather. So in future digital revolution, the data and decision-driven farming will be used, where vertical farming and various aeroponics or aquaponics, organic and hydroponics systems can be used. So in digital transformation, so what is the digital transformation? Digital transformation has been a strong theme in both business and IT over the past 5 years, and often as it is a term mistakenly used for almost any kind of new technology adoption. So it includes the digital transformation, which is the economic and societal effects of digitization and digitalization. So digitization means it is the conversion of analog data and processing into machine readable format. And digitalization, it is the use of digital technologies and data as well as interconnection that results in new and changes to existing activities. So digital technologies are the ICT which includes the internet, mobile device and data analytics, and it is used to improve the generation, connection, exchange, aggregation, analysis, access, searchability and presentation of digital content. So the technology mega trends are like for shaping future of food and agriculture sector, the digitalization is used, AI and machine learning is used, blockchain and big data is used. So in AI and machine learning business cases, the agriculture, the crop monitoring is there, the pest and soil defect detection is there, farm automation, predictive analysis, and the recommendation engine. So in which the precision agriculture can be defined as the application of modern information technologies to provide, process and analyze multi-source data of high spatial and temporal resolution for this decision making and operation in the management of crop production. So in crop monitoring, crop health monitoring using deep learning algorithms based on real-time data from sensors like satellite, drone images on ground farming practices and ground threatening techniques. And in pest and soil defect detection, the artificial neural networks to identify potential defects both in soil and plants. So image processing algorithms along with historic and current local pest, soil, weather and activity data, which is used for training artificial neural networks. And in farm automation, the machine learning techniques are used to care for plants by deploying UAVs and UVs, including the automated application of pesticides and plant nutrients, elimination of weeds, irrigation, like this. Then predictive analysis, it uses AI algorithms of yield and crop quality, input side demands, and for the output aggregation needs the learning of optimization of supply chain like input and output and the policy intervention. Then recommendation engine, where farming activity recommendations including the crop and the variety selection, the various crop nutrient and protection, and for showing irrigation, harvest timing and demographic agriculture and market profiles. So what is the precision farming? As already I told.
Pankaj sir.
Yes, sir.
Allow me to take from here, please.
Okay, sir. Thank you.
So good afternoon, everyone. Myself, Dr. Dinesh Goyal. I first of all thank MGM University and the World Webinar Foundation for giving us this opportunity. So I'll Dr. Pankaj Dadheech has given a beautiful outline and need of precision farming in country where we need lot of efforts towards automating agriculture, and government of India and industries both are coming together in India, especially countries like Netherlands have already done so. So we in next 10 minutes we'd like to understand what is precision farming and exactly how it works. So mathematically, it is defined as it is an integrated information production based farming technique that is designed to increase long-term, site-specific and more efficient production by the farmers, so that profitability can be increased, more output can be generated, and localized issues can be solved. Next slide, please, sir. So precision farming is not exactly a technology. It is a management technique which uses technology to resolve the issues of farming. Precision farming is improving farming by different ways, whether it's nurturing soil, nurturing seeds, health of plants, health of land, management of water resources, harvesting. Many stages are there into this. So it requires techniques and technologies at different stages, whether it's IoT, GPS systems, or any other to improve the quality of farming and increase the productivity. Please. Next slide. So precision agriculture started in 1990, where it was proposed in where in a Montana State University, it was proposed that a site-specific crop management. When we use the word site-specific, we mean if we have a land of 1 acre or 1 biga or any other dimensional measurements which we use, we can divide it into small parts and we can use it in a better way. So precision farming divides the farmland into management zones, whole field approach, where a field is totally treated. Today, if you go to any village or any farmer, they use precision farming as they use farming. हमने हमारे खेत में प्याज लगा दिया है या क्या नाम है आलू बो दिया है पूरे खेत में. It might happen that small part of the land might be having some issues with soil. They require more specific fertilizers. It might happen that some part of the land is not able to retain water. The soil quality might be different. So we use AI, IoT, and GPS can be used in precision farming, which can improve the productivity of even small areas. So to summarize this, need for precision farming is declining in total productivity, diminishing and degrading natural resources can be conserved. Stagnating of farm income has the issue which has to be resolved. Then lack of eco-regional approach, declining and fragment. These all issues can be countered if precision farming is done. It is a costly affair, but it can be sir, next slide, please. Precision farming is a costly affair. Is a costly affair, but if you have huge land or farmers come together, it can be held. It can be used to increase the productivity. So now components of precision farming, the technology which we as engineers play into. First is GPS system. GPS system, how it works is it divides the farmland into different components and creates actual information about each land part. So if it is a 1 biga land and we divide into 0.1 biga or 0.05 biga components, then we can have next slide will show the diagram also for this. So for each block we can have different information system, and accordingly decision can be taken. We can have data information of soil type, pest occurrence, weed invasion, water holes, as I said, boundaries, and any other issues which there might be, that the depth of soil is not that much, so you can't have soil root growing vegetables over there or fruits over there. Then sensor technology be used for measuring humidity. What is happening is a farmer has to travel all the way from his home to his land every time. Whenever he is available, water is available. If humidity measurement is available with him, he can do water management also properly. Temperature, texture, anything, health of the plants can be monitored by sensors. It can also help in managing the yield also. The GIS is a computerized map providing information of the field topography, so that as per this decision making can be done. What kind of crop is to be, allow me to have water, please. What kind of crop is to be placed, Then, so components of precision farming: crop characteristics, stage of crop health, nutrition requirement, etc. Details soil layer and physical and chemical properties, depth, texture, nutrition status, salinity. Then microclimate data about crop canopy, temperature, wind direction, and speed. Surface and subsurface drainage conditions, irrigation facilities, water availability, water cycle management, and other planning inputs. Farm machinery, equipments which can help in harvesting and all everything that can also be improved. So steps in detailed diagram of steps in precision farming is, first of all, we have two objective is to economic pursuit, reduced input, and environmental pool. These are the basic objectives. The GIS and GPS will use a vehicle provision system to improve the control, implement control and marketing. Then there's a GIS and GPS are used for management information, which will help you in decision, as I said in last slides, that you have the locational knowledge of your farmland, and based on that, machine learning and techniques can be applied to get that decision. Okay, this time you have soil data, you have rainwater data, you have last year's productivity information. You can take decision accordingly and plan this time this crop has to be taken care of, or this much water is required, this much fertilizer is required. Every decision can be taken accordingly. And output will be increased efficiency, low environmental impact, and less wastage of fertilizers, water, or anything like that, and that will lead into improved gross margin. So precision farming not only is potentially more economical, but it is also reduces the amount of chemicals releases in the environment. Other benefits are improved crop yield and profit, provides better information for making management decisions. We can skip this slide, sir, further. PF has three components, as I said, precision farming, like capture of data, interpretation and analysis of the data, and implementation of management response at an appropriate scale and time. Next slide, please, sir. Next slide. I'll go to this part. Yeah, and we'll close with this slide. This is the complete precision cycle, precision farming cycle, where the data processing is done based on the last year's data. You have the data. You accordingly that you manage your yield. The fertilizers are being implanted. The planting is done. The fertilizing is done. The spraying of water and medicine is done. Scouting is done, and again the harvesting is done. With I think if the precision farming is used in countries like India, we can become world leaders in many crops, like we are in rice as on date, where a lot of precision farming is used in southern part of the India. Thank you for this opportunity. Thank you, everyone.
Thank you, ma'am.
Okay, sir, stop slide sharing, please.
Thank you, Doctor. Dr. Pankaj and Dr. Dinesh.
Yeah, thank you so much, Dr. Dinesh Goyal sir and Dr. Pankaj Dadheech sir, for your guidance. Our next speaker is Dr. Kranti Ghar. She is currently working as an associate professor at DJ Sanghvi College of Engineering, Mumbai. Her disciplines include databases, artificial intelligence, data mining. She has expertise in natural language processing, sentiment analysis, data mining. I request Dr. Kranti ma'am to speak on sentiment analysis on Twitter data and movie review data set using Colab Notebook. Ma'am, over to you.
Thank you, ma'am. I hope my screen is visible and I'm audible.
Yes, ma'am.
Thank you. Yeah. So to start with sentiment analysis, how do we, or what is basically sentiment analysis? When we have the platforms which are worldwide available, where people can write different things on their using different devices, maybe a laptop, maybe a computer, maybe a handheld device all around the world, they write their emotions. So sentiment analysis involves collecting these reviews, processing these emotions, computing them, and presenting it in a way to any of the name user who's not aware of the entire system at the background. But these results help this person to take decisions. Maybe like here, what we are going to discuss today is a movie review data set. So traditionally, people used to ask their friends, families, rely on the critics' review to take the decisions. Now, instead of that, you can have the sentiment analysis look of the reviews and go ahead with the decisions. This is what we do most of the times when we do online purchasing or decide whether to watch a movie or not. So here you see a graph which I had, which is just for a illustrative purpose. I had plotted it in R, where we plotted different sentiments. So you can see the sentiments over here and the level, the intensity of that sentiment on that date. So this was 1st June, this was on 2nd June. You see the difference of the intensities specifically for sentiments like joy is very high on 1st June, or something like positiveness is very high on 1st June. There's a lot of reviews shared on the 1st June, probably the salary day. So that is why. Whereas on 2nd, you see a relatively lesser number of tweets or lesser intense. I don't say number of tweets, but less in the intensity of the tweets. We use these two libraries for pre-processing the tweets and for setting the environment to access the tweets from Twitter. So I've already executed these two. What the environment that I'm showing you is the collab environment, which is as good as we access our Google Drive. In the same way, we can use the collab environment. So like this is a folder in my Google Drive where we see all the files, and we can as good as share it just like any folder, any file which we share on our Google Drive. So that's the beauty of using collab. And then these are some of the libraries that we need. Here, what you see is really important. When we want to access data from Twitter, we have to have a user's account. So this are the details related to my account. And then we go to developers Twitter developers platform. There you can access these details, which I have set, which you can change this. So after the session, I'll be changing this for a day or two. I'll keep this resources as it is, but afterwards you can access your own details and add it and see. So this is how you can access the Twitter. You can access the tokens, and we are using this API VP. So we are just giving this keyword as sentiment analysis and see what are the two tweets that are extracted. So given this keyword as sentiment analysis, we see this is a tweet which is there. Okay, now we try to do something beyond that, where we are trying to give any keyword and try to access what are the emotions related to that keyword. Let us say I give keyword as iPhone, and we go ahead, which just print the reviews or the tweets, sorry, not the reviews, the tweets where this keyword iPhone is there. So we have printed the tweets. And then you see the tweets includes everything. There's percentage, there's dollar, there are links. So we need to pre-process these tweets. We need to clean the tweets. So we'll be doing it here using this clean tweets.append. So clean tweets is the function basically, and we are collecting them together by appending. So this is how our clean tweets are looking. It's now in one set together. We are then using a library called as text block, which has the sentiment scores associated with every word. So every word that you see printed over here, you will see the sentiment score associated with that word over here. And what we are doing finally is aggregating this sentiment scores, averaging this sentiment score to get what is the average sentiments about that product. So here we can see the value is positive, indicating that people have positive sentiments towards iPhone. Now this is one set of codes or definitions that I had written where we can compare. So this is one product, and there's another product where we are comparing the scores of two products or any two keywords we can give over here, that could be compared. So let us say I'll give as, again, I'll stick to same iPhone, and the second I'll give as OnePlus. Oh, now what the result is, public prefers, which we think is a general sentiment, but it keeps changing. In last session where I had conducted, I was seeing, or last two sessions rather, I'd seen as public prefers OnePlus, but now the sentiment is changed to iPhone as compared to OnePlus. So this is how would be useful for commercialization. Also, people keep a track of their products, see how what competitors feel about their products and all. So that is one notebook that I have, and I'll be sharing the link to this notebook in our chat. And I'll share it afterwards after I stop sharing my screen. I'll go to the other notebook right now, which is, we are going to do a sentiment analysis on movie review. So here we were accessing the data in the Twitter sentiment analysis, the first notebook that we saw. We were accessing the tweets directly and working on them. We can of course save it in a CSV and work on them, but sometimes we need to work on standard data sets. So for which we are going to see the next notebook, which is the sentiment analysis for movie reviews. Again, some libraries which we are not going discussing right now in detail, but we need these libraries because they'll have the functions that we are going to use. Now here we see an option to upload the file that we want to perform the analysis on. So this is the link to those movie reviews. Actually, this is a link to the movie reviews as well as hotel reviews, as well as the product review. So 3 data sets are available over here. It's a UCI data set. So I've already loaded it, but we can just execute. Once you run this, you will get an option to upload a file. So you can upload the file, like I have downloaded these data set, and it looks like this. So I uploaded this file, IMDb labeled. So I've just opened it also. So there are reviews like this: saw the movie today and thought it was good effort, good message for kids. And one indicates that the review is positive. Whereas if you have a tab with a 0, indicates that the review is negative. So very little music or anything to speak of. Something like this. The short film certainly pulls no punches. So negative review with 0 as a tag, indicating that the review is negative. Now we're trying to load this file into our code. So we come back here. So we are creating a data frame where we are reading our file into this data frame. It's successful. Then I execute the next thing to confirm that it is loaded properly. So if we see data frame.head, it is going to show you the first 5 reviews. So you see over here that the first 5 reviews are loaded, and the review value and the sentiment value. Okay, so we specified the column names are review and sentiment. I could even write tail over here, which would show me the last 5 reviews. So that confirms we have 474, or rather it starts with 0, so 478 reviews. To just know how many rows and how many columns, yeah, so 478 reviews and 2 columns. One is review and the other column is sentiment. You're then going to see whether, see, some reviews are 0, some reviews are 1. We had seen it in this file, in the text file. Some reviews are 0, some reviews are 1. So we're going to see, is our data set balanced or not. So we are just plotting by review count on sentiment. So for 0, we see there are nearly slightly above 350, and for 1, the more reviews are there, but nearly balanced. There isn't a huge difference. So if the data set is unbalanced, we would have need to do some other processing and see how it is. In the next part of the code, we are attempting to see how is the what are the prominent words in this data set which is given. So one of the innovative ways is word cloud. So we are loading our data frame in this word cloud. So you can see the prominent words like film, movie, good, great. And you have character, script, and likewise. So this is about just playing around with the data set. Now we come to the actual AI part of it. Okay, we're doing it by machine learning, ML part of it. And this is now we have our review data frame DF movies. We are going to split it into the training set and testing set. So we split it into training set and testing set with the size of 80%. So training size is 80%, testing size is 20%. Just to confirm, we print the train shape. So we know that 598 reviews are there. Now what does this do? Train test split our entire data frame which was there, DF movies. It will divide DF movies into column wise as well as row wise. So we will have 80% of reviews in Xtrain. Okay, 80% of the review sentiments in Xtest. Let me just show you also. So these are 598 reviews out of the total. And the remaining, which are there is a the Y part of it, that is the sentiment part of it. So 496 review which you see over here, you won't regret it. The sentiment of that is in Y train. So it has divided our data set into 4 parts: X train, X test, Y train, and Y test. Now what will we do with these 4 parts? We will use X train and Y train for training our data set. We'll use X test to predict the results, and whatever are the results, those we will compare with Y test to see how good the model is. So how do we do that? We are going to create, as sir has mentioned earlier about the TF-IDF vectorizer, because document data, as you see here, there is no table structure, but for machine learning, we need a tabular structure. We need a tabulated data. So how do we do it? We do it using TF-IDF. And what would be the major use? We identify the important words. So this is once we gave our reviews to this TF-IDF vectorizer, it has generated the vector which you see over here. So achievement is one of the words in this vocabulary. Then along is one of the words. Amaze is one of the words. Likewise. So for this vocabulary, whatever is there, okay, it is there for entire DF movie, the entire movie review data set. Now we will generate this vectors for train, Xtrain and Xtest both. So you can see over here, your vectors are generated. It means that for sentence 0, there is a word which is 3026, whose index is 3026 in the vocabulary. So here if I start with this index, this is 0 index. Likewise, some word which is at the index of 3026 has the TF-IDF score of 0.33. And when we just check for each one, that means we have a vocabulary of the size 3074 words. So 598 training reviews, 150 testing reviews. Then we apply the training model, which is logistic regression model, and we fit the data over here. So we have given this Xtrain TF-IDF, because we can't give Xtrain directly, it's purely text. So we have now converted into a tabular format. Y-train is a single column, so we can give it as it is. So we are making this model, which is a logistic regression model, and you can see the output. Then what we are doing is we will be using this model with Xtest, and we will be using the score as the accuracy. We are using the score as accuracy, but there are many other options like precision, recall, F measure, F ratio, likewise. And we also see the classification report in detail for all these measures. So you can see also the popular way of seeing the results is viewing a confusion matrix. So we can view the confusion matrix. This is a graphical way of showing the confusion matrix. If you look at this confusion matrix, we know that 50 of them are correctly classified. 50 reviews which were negative are correctly classified as negative. 60 reviews which were positive are correctly classified as positive, but whereas 18 and 22 are incorrectly classified. Although not that great accuracy, but much better one. Next one, what we see is we can actually give one review as we give one input and see the output. So I've given a good Bluetooth headset. You can see it is predicted as 1. There will be certain conditions like sir mentioned for context aware and all. It won't work, but for some basic things, the system will work well. So I say worst Bluetooth headset, the sentiment what we see is 0. With that, I would like to conclude my session. Thank you to all. And I'll share the links in the chat.
Thank you, ma'am, for the valuable words. Next speaker is Dr. Fabiana Sepe. She's an assistant professor at University of Naples,
Yes.
Federico, Italy, and she has disciplines in managerial economics. She has expertise in strategic, business, marketing management, business development, entrepreneurship, strategic planning, innovation. Dr. Sepe will throw a light on AI for social robots in airport setting. Over to you, ma'am.
Okay, just 1 second. Are you able to see the screen?
Yeah, we are able to see.
Okay, just the slides.
Yes, ma'am, it is visible. Please go ahead. Yeah, please.
Okay. Hi, I'm Fabiana Sepe. I'm assistant professor at the Department of Economics Management Institution of University of Naples Federico II, based in Italy. And today I will show you a research paper we are working on with other, research members. Research team members, and the topic is on artificial intelligence for social robot in airport setting. I will focus on different points in our research agenda. So starting from the introduction, then we will I will focus on research aim and research questions, then the theoretical framework, hypothesis development. I will suggest a proposed model, a quantitative one, and I will show you also what is the methodology we adopted and the preliminary results, besides the theoretical and main managerial implication, research limits, and future directions. I would like to talk about the setting, the airport setting, and what is the use of social robot in this specific context. We know that artificial intelligence is playing a very important role in the travel industry. In this context, customer service and in general, the global experience, is a focal aspect. In particular, social robots capable to follow humans' behavioral norms and interact with humans have become the most competitive candidate to deliver high human touch services. Some scholars have proved that artificial intelligence robotic technology used by firms such as, airport companies can alter customers' evaluation and acceptance of different services. Specifically, if on the one hand, the adoption of these social robots may improve customers' perception of service quality and performance, resulting in a higher willingness to use these technologies. On the other hand, the lack of social interaction caused by using social robots may lead customers to feel, isolated, so determining some difficulties in accepting the use of these technologies. Before the pandemic, airport companies were skeptical about the use of the social robot, since human touch is considered a core competency in travel industry. However, today customers are willing to explore also safer options. Starting from this assumption, this condition, we have defined our research objective and research questions. So we can skip to the next slide. These studies advances the social robots adoption literature by extending the theoretical IDA framework that is derived from the literature Gursoy et al. 2019 to predict the customer's intention to use social robots during the travel experiences, investigating on two important variables, the trust, the trustworthiness, and analyzing also the role played by the misophobia effect. So what is the role played by the COVID-19? Based on this research aim, we formulated two different research questions. What are the antecedents of customer acceptance or, rejection towards the use of social robots in the airport context? And what is the effect of COVID-19 on customer attitudes towards social robots, and have these attitudes reversed in a new robotic society? So we start from defining the theoretical model. I don't know if you are, have expertise in the management field in social behavioral studies, and many theoretical models have been used to explain and predict user acceptance of information and communication technologies. The most representative ones are the technology acceptance model and the unified theory of acceptance and the use of technology. But since artificial intelligence technologies, like the social robots, have unique characteristics that are very different from traditional technology, these theories and frameworks seem to be not so useful for the study of the customer's attitudes toward the use of artificial intelligence devices. So in this direction, we suggest the use of the IDOA model, and the framework, the model is like you can see here in the screen, and we add just two different variables construct, like I explained before. Trust in artificial intelligence and misophobia effect. Trust. Some recent studies argue that incorporating trust as a critical determinant of performance expectancy within technology acceptance model is very, very important. Moreover, high level of trust is positively related to the effort customers are likely to sustain to interact with social robots. Moreover, misophobia is an irrational fear of contamination or germs. By reducing human contact, many airport companies have elevated their safety and cleaning protocols, also ensuring high levels of safety, thus alleviating customers' fear of infection or contamination. In this circumstance, individuals that are particularly fearful of contamination are likely to use social robots. So starting from the model, we defined also our hypothesis like the model I showed you before. And as for the methodology, the data have been collected using the survey questionnaire designed from previously validated scales adopted in the literature. All the items are measured using a 7-point Likert scale, and also we collected some demographic information, so age, gender, income, and so on. The first section of the questionnaire provided a brief description of the study, which highlighted the purpose of the study and the service context, the airport one. And this is, the table with the reference to all the constructs, so misophobia and trust, and the other one. So we collected within two main clusters, heuristic factors and systemic factors. We proceeded with the data analysis. The data collected have been studied adopting PLSM, so the partial least squares approach to structural equation model. This approach is used when the type of relationship is complex, containing the first order and second order construct, as in our case. PLSM is appropriate for both small and large samples, as well as for non-normal data. Moreover, we choose PLSM because our focus is on understanding the relationship between the constructs instead of fitting a model. Finally, this approach does not rely on any items distributional assumption, so it is not possible to evaluate a global fit measure, and the model validity is assessed using a two-step approach. The first one is the quality of the measurement model, and the second one is the assessment of the structural model's predictive power. As I said before, this is a working paper, so we are always collecting data. Up to date, we have obtained more or less 250 responses, which confirm our hypothesis, but the sample is still too small to be able to generalize the results. Our goal is indeed to collect more data and test the complete model. As for the theoretical and the managerial implication, I mean, what is the contribution of this work for the academic world? So first, the study advances the social robots adoption literature by extending this existing model, I mean the IDA1, to predict customers' intention to use artificial intelligence social robots in their context. Then the study also investigates the role of trust and misophobia in the acceptance of social robots in their context. And as for the managerial implications, this study can help managers to better understand what could be the drivers of service robots acceptance in hospitality industry, and so to choose and to evaluate if there is the possibility and is the case to introduce this social robot in their context. So to suggest managers where to focus the resources to introduce and or improve the use of service robot in the airport and in the travel industry. What is the research limit? First of all, we focus just on one country, and we have not considered the potential inhibitors that may influence the willingness to use robots in the airport industry. I finished, and I would like to thank you everyone for your kind attention. Have you some doubts, questions?
Yeah.
Sorry?
Thank you.
Thank you. Thank you
Yeah.
to everyone for the invitation.
Thank you, ma'am. Thank you so much. Yeah, our next speaker is Mr. Igor Jurcic. He is currently working in business marketing at HT ERONET, Bosnia and Herzegovina. He has disciplines in electrical engineering, telecommunications engineering, computer engineering. He has various skills and expertise in business, marketing, innovation, project, strategic, and change management, strategic planning and analysis, business consulting, business analysis, technology and innovation, telecommunications engineering, SMEs management, new product, business and strategy development, electrical engineering, managerial economics, computer engineering, business economics, advertising, public relations, telecoms, business model innovation, leadership, strategic thinking, organizational theory and learning, Internet of Things, information and communication technology, operations, production, industry, innovation studies, human-computer interaction, electronic engineering, media, Twitter, social networks, radio, mobile networks. So we are very fortunate to have you here, sir. I request Mr. Igor Jurcic to share his knowledge on importance of AI applications in Telecom 4.0 business. Over to you, sir.
Good morning, good afternoon. Thank you for this opportunity. On the first place, can you hear me?
Yeah, we can hear you, sir.
Okay, can you see my screen?
Yeah, it is visible.
Okay, excellent. Okay, well, let's start. Once again, my name is Igor Jurcic, as you said, and I will explain you importance and roles of artificial intelligence applications for Telecom 4.0 business segment based on a comprehensive techno-economic model. This model is my own model that I developed for my PhD thesis. And as I finished it, I'm expecting to have my final PhD exam in following 2-3 months. So I will explain you how important is artificial intelligence for telecom business based on this CTE model. At the beginning, I will explain you my model, how it works. We all are living now in the Industry 4.0 era. Industry 4.0 era will bring changes to all businesses. On the first place, the biggest impact of telecommunications and ICT business segment. Each companies from telecommunications business segment will have to change themselves, and telecom operators are on the top of that list. When we speak about modern telecom operators, they will have to change. On the first place, their business approach. On the second place, their organization or their organizations. Then products development approach and services development approach, and of course, customer approach. Many other different important issues if they want to be competitive, such as financial or HR issues, etc. But here I listed the four, let's say, the most important ones. Why a comprehensive techno-economic model? Why I used this model for analysis of artificial intelligence for telecom operator business? On the first place, there are many different models for analysis for telecom operators. Almost all of them have partial approach to analysis, and many of them are significantly complex for very often analysis. This model, CT model, for analysis of telecom operator potentials will significantly help them in their transformation processes. Why? This model will enable fast, reliable, and easy analysis of the potentials of the entire telecom operator, but also of individual parts of it, regardless of other parts of the company. The main advantages of this model are, on the first place, simplicity, then speed of telecom analysis, accuracy of results, and its modularity. It means independent evaluation of individual parts if we want to do that. How it looks like? This model has 3 levels: technical level, business level, and environmental level. It consists of 14 segments, and because of the fact that each segment doesn't have the equal worth, all segments don't worth equal, 14 segments create 8 areas, and all areas or segments consist of different items. What are the 14 segments? Coverage and accessibility to users, technological and development, and IT development. These 3 segments are part of technical level. Then we have products development, services development, sales, customer care, and human resources. These 5 segments are parts of business level. Then we have 6 segments: political environment, regulatory environment, law environment, finance environment, quality of brand, and presence in public. These 6 segments are parts of environmental level. But as I said, each segment doesn't have the same worth. So we have 14 segments, but we have 8 areas. When we speak about areas, on the technical level, we have 2 different areas. Coverage and accessibility to users are a segment and area at the same time. But this second area of this technical level is technological development and IT development. So 2 segments are joined into 1 area. On the business level, we have 4 areas: product development, services development, sales and customer care, and human resources. As you can see, there are 4 areas on this level. So it shows that telecom operators has to be business oriented, not technical, but business oriented in following years and following decades. Then we have environmental level, and we have 2 areas: political, finance, regulatory, and law environment. And we have the second area: quality and brand and presence in public. First area shows impact from environment to the telecom. The second area shows impact from telecom to the environment. The results of this model will be presented as total amount of CT model for individual telecom operator. We have to know that total area value of each area is 1, so the maximum value is 8. Each item value in each area can be will present some parts of telecom, and we will have tabular and graphical forms for easier comparison of telecoms if we want to compare 1, 2 or 3 or more telecom operators. Now let's see artificial intelligence and its importance for Telecom 4.0 business operators through this model. City model, as I said, is defined by levels, segments, areas, and items. Levels and segments are unchangeable parts of model, and areas are created by segments, and they could be changed in following years in the future, but it will be defined according to new research, which will be carried out for many in following years and even decades. Items in areas and segments are defined, but they are changeable, and they will be changed as telecommunication markets will be changed in the future. Of course, they will be changed and adjusted according to these changes in telecom business segment, but also in complete ICT ICT business segment. At this moment of evaluation of CT model, there are no artificial intelligence segments or items in CT model. So there are no separate segment or separate items when we speak about artificial intelligence. But there is possibility for one or several items in following years in the future. At this moment, we don't have any separate items. But at this moment of evaluation of CT model, artificial intelligence applications in telecom operator can improve results of their items which are defined in these segments or areas. So artificial intelligence applications will improve and will help that other results of other items will be better if we use artificial intelligence in the telecom business segment. When we speak about different areas, marketing and sales, when we speak about personalization and lead generation, we can improve results at this moment up to 1.5% with usage of artificial intelligence. We can have better churn management results up to 1.5%, upselling and cross-selling up to 3.5%, pricing optimization up to 3.5%, and precision of the use of the media up to 1%. When we speak about network and operations, network rollout optimization will be better 1.5% if we use artificial intelligence applications in telecom operator. Network asset optimization can be better up to 1.5%. Field force labor optimization up to 3.5%. Predictive maintenance up to 3.5%, and customer service up to 1%. So we can have less expenses and higher income if you use artificial intelligence at this stage of development of artificial intelligence. When we speak about support functions, different support functions regarding financial forecasting, contract and document processing, HR, etc., we can have better results up to 5%. So by usage of artificial intelligence, we can have better results in telecom operators from 1 to even 5%. And of course, we can have less expenses if we use it, or higher income if we use these applications. As I said, the maximum amount of CT is 8. In ideal situation, this amount can be larger based on positive forward-backward interconnection links. I really don't have time now and space to explain these links, but you can find it on my ResearchGate profile if someone wants to see this deeply. And based on implementation of artificial intelligence applications in telecom functions and operations. For example, if CT model gives remark 5 for telecom operator potentials, it is possible to be larger several percent because of artificial intelligence implementations. That means that that remark can be even 5.15 or 5.20 if we use applications of artificial intelligence to get better results. According to some research that I found on the internet, the following assumptions were made. Artificial intelligence will equal human intelligence by around 2040. Artificial intelligence will highly exceed and be superior compared to human intelligence by 2060. Maybe before, but I found this data and I use it for this presentation. So in the future, by 2040 or by 2060, influence of artificial intelligence will be much higher. It is hard to estimate the percentage of this influence, but let's say that if it will be 10 to 15% or even more, it is huge amount for these results. That means if telecom operator with remark 5, and if it use artificial intelligence applications, can have a remark up to 5.5 or even 5.75. Artificial intelligence applications really can help, and in the future will help more than now, that we have better results, less expenses and optimization, and higher results of income. Typical cases of artificial intelligence in telecom that I found on some operators. I don't want to promote operators on some vendors of these applications, but when we speak about networks, intelligent NFV, network function virtualization platform, is one of the options for usage of artificial intelligence. Of course, we have SDN platform, IPTV, SDN, NFV optimizations, etc. In the future, artificial intelligence will be used for better results in 5G or 6G networks, satellite broadband networks, and quantum networks. When you speak about services, now we have implementation of artificial intelligence in smart home services, smart city, building, traffic, etc. In the future, it will be much more used, as we said in one presentation before, in smart agriculture, smart healthcare, smart factories, and smart mobility. When you speak about industries, retail business, energy business, transportation, smart city frameworks, etc., and in the future, improvement of Internet of Things, over-the-top applications, software as a service applications, platform as a service, infrastructure as a service, and anything as a service will be better and will have better results with artificial intelligence. When you speak about platforms, we have now many different platforms, open source artificial intelligence platforms. In the future, there will be much more, and we have to cover all of these platforms with services to get better results for modern telecom operators. Now I will conclude that artificial intelligence has and will have a strong influence on telecom operators and their potentials in the future. This influence, according to some researchers, will be much higher in the future by 2040 and even 2060. Artificial intelligence applications will be crucial for telecoms, for less expenses, as I said, and for higher income. Artificial intelligence applications vendors have huge opportunities in telecommunications business segment. And when we see about Industry 4.0 and telecom operators and artificial intelligence, I always like to cover this with this slide. In telecom operator in the future, and if we compare it with train composition, train driver will be artificial intelligence. So we know all what is importance of train driver, and artificial intelligence really will be that train driver in further composition for telecom operator. Thank you for listening. I do hope I explained importance of artificial intelligence in following years and importance for telecom operators.
Thank you so much, sir. Now the session is open for question and answers. I request all the participants to ask questions, if any. Please feel free to ask. You can unmute your mic or type your question in the chat box. No.
Yeah, David, you can unmute and you can take questions.
Good afternoon, sir. Hello, good afternoon, sir.
Yeah,
Hello,
good
can you
afternoon.
hear
Go ahead.
me? Thank you,
Yeah,
sir.
yeah, we can.
Please, my question goes thus. The AI intelligence, is it only working in telecom operations? Hello?
Okay, Igor, can you answer this question?
Sir, I said
Sorry,
the AI.
sorry. Can you repeat? I didn't hear.
Okay, the AI, is it only working in telecom operations alone, or is there any other sector that it can be useful?
I really don't understand. I can't hear you. I'm very sorry.
Oh, hello.
Bad connection. I can't hear you. Sorry. I remember telecom sector, but what is the main question?
Hello, I said advanced intelligence. Is it only working in telecom operations, or it can be used in any other sector?
Artificial intelligence applications are used at this moment in some bigger operators, such as Vodafone, such as Deutsche Telecom, AT&T, Verizon Wireless, etc. But in the future, it will be available for many other smaller operators for better results regarding some less expenses and high incomes. And if you see, when I mentioned product development and services development, pricing optimizations, especially in these areas, it will be helpful for all especially smaller, let's say smaller operators.
Okay. Thank you, sir.
I can send you my email, and if you want, I can send you better presentations with more slides, and I can answer you by email. But I really didn't understand very well. The connection was very bad.
Okay, sir. I will send my email on the chat room, sir.
Okay. Thank you.
Yes, sir.
Hello,
Anyone
good
else?
afternoon.
Yeah, please go ahead.
Hello,
Yeah,
good
next
afternoon.
question. Next question.
Hello, can you hear me?
Yeah, go ahead.
Okay, my name is Asimo Binameka. I'm trying to find out, for example, if we have traffic on a particular base station that is carrying 2G, 3G, 4G in a campus environment, and we have another location having residential and a little bit commercial services running there, and it's also carrying 2G, 3G, and 4G traffic. Is there a way whereby we implement artificial intelligence in the sense that if it's able to detect that there are low users for the traffic required that is being given to the campus environment, that can be transferred now to support the traffic for those in the commercial area?
As I understand, at this moment, I didn't find any special artificial intelligence applications for 5G or even in the future for 6G. As I mentioned, it will be applications for following years or decades. At this moment, artificial intelligence is used more for software-defined networks and self-healing networks between base stations. But for optimizations base stations, maybe there is some opportunities and possibilities for mobile operators. But I believe optimization of 5G or 6G mobile traffic in the future will be developed in following years. At this moment, I didn't find any practical solutions for optimizations of 5G mobile network. Only in SDN, NFV, and for some applications such as smart cities or smart factories, etc.
Okay, then if I can ask my second question, I don't know if I can ask my second question. Hello?
Yeah, I can hear you. I'm waiting.
Okay. As regards integrations of cell sites, perhaps maybe trying to implement 2G, 3G, or 5G, whereby we normally have to require a back office engineer to do the integration. Do we still see artificial intelligence trying to take people out of jobs, whereby the system is going to do the integration by itself? Because normally for now, we have human beings are the ones doing the integrations of 2G, 3G, and 4G. If we bring in artificial intelligence to do the integration, with time, most people will be out of work.
In my opinion, I'm not sure, but I can say in my opinion, 2G, 3G, even 4G, you can forget when you speak about artificial intelligence, because these applications are developed and will be developed in the future for 5G, 6G, or even 7G in the future, and satellite communication. So when you speak about 2G and 3G, maybe some companies, some artificial intelligence open source vendor will develop some parts of these applications, but when we speak about artificial intelligence, in my opinion, you can forget on a 2G or 3G or even 4G mobile networks.
Okay, thank you very much.
Thank you very much. Thank you for your questions.
Yeah, thank you so much. We are very grateful to all the speakers for putting so much effort in guiding the audience despite their busy schedule. All the sessions were highly informative. Now every participant is aware of all these techniques which we have listened in the workshop. A big thank you to all the organizing team, and looking forward to a similar kind of association with you ahead as well. So participants' feedback link will be emailed to you very soon. I request everyone to give genuine feedback. And I declare that this is the end of today's workshop. Thank you for attending this workshop. Take care and have a wonderful day ahead. Thank you so much.
Thank you and best regards.
Thank you, Professor Tamane. Thank you, everyone. Thank you all.